GPU ecosystems in flux. AMD's ROCm 7.9 pre-release stirred anxiety among owners of older accelerators like MI50, MI100, with documentation signaling deprecated support for GFX 906, even as community sleuthing found nightly the ROC builds that still target the arch. The official ROCm 7.9 tag exists, but commenters note this drop is a pre-release of a new build system for ROCm 8.0, with 7.1, 7.8 planned as production releases. Meanwhile, a pip install workaround using the GFX 90X DC GPU nightly link appears to keep GFX 906 alive for now. Translation: documentation says deprecated, the ROC says not dead yet, and the long tail of AMD GPUs lives to see another day, at least for tinkerers. On the consumer side, Apple's M5 is the new unknown quantity for local LLMs. Llama.cpp is soliciting performance testers for the M5 neural accelerator, while early coverage shows MLX builds tapping the updated GPU hardware, but third-party benchmarks from LLM specialists are still thin. The ask from the community is simple. Apple should seed devices to LLM devs to accelerate upstream support, especially for GGUF-friendly pipelines. NVIDIA, for its part, is leaning into the local stack as well. A developer reports the company sent them a GeForce RTX 5090 to demo Qwen 3VL running in GGUF format, another nod to the momentum behind efficient, vendor-agnostic runtimes like Llama.cpp for multimodal inference. It's vendor outreach with a very specific subtext. Local, lightweight formats are strategic. AI security frameworks and browsers. There's a fresh reminder that model frameworks can be high-value attack surfaces. A critical issue in NVIDIA's NeMo toolkit, CVE 2025-23313, led to potential system compromise, with fixes landing in the 2.40 line per NVIDIA's security communications. The PyPI and changelog trails don't annotate CVEs directly, underscoring a recurring pain point for developers. Security patches matter, but clear versioning and explicit CVE notes make risk management tractable. Agentic browsers present a broader class of problems. Brave's latest research shows that indirect prompt injection is systemic, not edge case. Perplexity's Comet Assistant could be steered via nearly invisible text in screenshots. OCR pulls the hidden strings, and the agent treats them as trusted instructions. Fellow routed page content into the LLM on simple navigation, allowing visible on-page instructions to override user intent. Once an agent acts with your authenticated session, old sandbox assumptions, like SOP or CSRF mitigations, don't save you from an LLM convinced to click the wrong thing. The call to action: isolate agentic browsing from regular sessions and require explicit user invocation before agents get tool access. Don't see local-first coding agents. Offline-capable coding agents are getting sharper tool belts. VT Code, a Rust-based terminal agent, now supports a Llama alongside cloud providers, pairing AST-aware refactors via TreeSitter and AstGrep with tool safety controls and Z integration. It means structural edits with reproducibility on local models, an appealing middle ground for teams that want agentic help without shipping source to third-party APIs. Keeping code on track benefits from fresh, targeted rules, not giant sticky notes. A path-based pattern injection workflow gives the AI file-specific rules just before generation, then validates the result with a post-hoc review tool. The system exposes two model context protocol (MCP) tools: get file design pattern pre-gen and review code change post-gen, plus severity levels that drive automation: low, medium, high. After categorizing 500-plus violations, teams reportedly cut false positives by 70% and lifted adoption to 92%. The takeaway matches experience. Put the right constraints in the model's short-term working set. Verify immediately and let humans arbitrate the edge cases. Debugging is joining the MCP party too. FlowLens records video, logs, network traffic, and user actions, then hands agents the whole package via MCP in a structured form. Paired with local PII redaction and developer review, it turns explain the bug into here's the session graph, collapsing back and forth and giving coding agents the same context a human would want. Building with AI 4. A live example of AI-assisted vibe coding. Simon Willison used Claude Code for Web to build a paste-to-HTML terminal sharing tool that exports to GitHub gists and renders via gist preview. The interesting part is not the feature, but the pattern: compose new tools by referencing existing ones in the repo, Do what OpenAI audio output.html does for auth, and let the agent glue it together. It's a practical demonstration of why repository local conventions are so powerful for agentic development, and a reminder that the more tooling you document in repo, the better your agent can reuse it. Of course, the same piece surfaces a cautionary drumbeat that aligns with the agentic browser research. Prompt injection remains a real risk in powerful assistance. The right response looks like defense in depth, tight tool scopes, explicit user consent for dangerous actions, and workflows that degrade gracefully when automation hits ambiguity. Model access meets limits. Anthropic's Max 20x plan is drawing criticism for how quickly Opus usage burns down under deep research or even routine chats. Reports cite 2% of weekly Opus for a single deep research query, with follow-ups doubling the hit, and some users seeing ordinary prompts consume multiple percent each. Official guidance emphasizes Sonnet Haiku for sub-agents with Opus as the final reviewer, but users argue the delivered capacity falls short of promises in dev docs. Either way, the effect is predictable. Developers seek local or cheaper options for sustained workflows. Agent research grows up. Agentflow proposes a modular agentic system, planner, executor, verifier, generator, coordinated by evolving memory and tool APIs, then directly optimizes the planner using flow-based group-refined policy optimization, Flow GRPO. The authors report beating top baselines across 10 benchmarks, with positive scaling trends and claims of surpassing even 200 B-parameter proprietary systems on certain tasks. The framework supports diverse tool backends, e.g. browser, code, search, and provides quick-start inference and RL training scripts, emphasizing planner-centric learning for long-horizon tool use. On the practice side, an engineering leadership account details orchestrating agent swarms to ship a quality-hardened release, Agentic QE 1.20, in 3 days, pivoting midstream from bespoke networking learning code to AgentDB. With 5959 tests passing and a quality score jump from 68-100 to 82-100, the narrative emphasizes rigorous verification, parallel execution, and decisive architectural simplification under time pressure. Multi-agent content pipelines are also getting polished UX. Sunlong coordinates agents via LangGraph for requirement analysis, parallel web search, extraction, structured generation, and review, with exports to Markdown, HTML, PDF, docx, PPTX, and observability via LangFuse. It's a comprehensive take on Write Me a Report or PPT end-to-end, using external docs as high-priority context and supporting iterative refinement. Context, compression, and RAG. If longer context is the blunt tool, compression is the scalpel. A proposal dubbed Unlock claims up to 3 times context compression at 93.65% accuracy, promising cheaper long-context reasoning if those numbers hold under independent evaluation. It's an attractive complement to bigger windows, especially for retrieval pipelines that bloat prompts with near duplicates. Caveat emptor until peer comparisons and public code data land. On the bigger window front, GLM 4.6 extends context to 200K tokens and reports better coding, reasoning, and tool-integrated agent performance over GLM 4.5, with competitive results versus models like DeepSeek v3.1 Terminus and Claude Sonnet 4. Recommended sampling parameters, e.g. temp 1.0, for code top p equal 0.95, top k 40, reflect a lean into generative diversity for code tasks, and the release foregrounds stronger tool use during inference. For knowledge-grounded workflows, Liquid AI's LFM.2b RAG fine-tunes a 1.2b model specifically for document-conditioned QA, multi-turn, multi-document, with a ChatML-like template and guidance to run greedy decoding at temperature 0. The emphasis is practical RAG. Inject fresh or proprietary context, answer deterministically, support multiple languages, and keep the model small enough for responsive applications. GGUF versions and Transformers templates simplify deployment. The web shifts again. Google is redrawing the privacy sandbox map. After feedback and low adoption, multiple APIs across Chrome and Android are being retired, while others like Chips and FedCM continue with broad support. The company will focus on interoperable standards for measurement via the W3C Private Advertising Technology Working Group, plus anti-fraud approaches and publisher-requested controls for first-party data and better web experiences. For developers, the signal is clear. Expect consolidation around fewer, better-supported primitives, with attribution and identity flows as the center of gravity. Combine that with the agentic browser findings and the lesson is sobering. The platform is evolving on two fronts at once: privacy economics and agent safety, and both will influence how AI tools browse, summarize, and act for users. Isolation layers and explicit user invocation aren't just security hardening, they're emerging UX norms. AI for music, from notes to notation. The open-source music intelligence stack is quietly converging into a powerful loop. Autoveris turns PDF scores into structured music XML, linking classic vision heuristics and modern neural recognition so even complex, multi-page works can be digitized with minimal cleanup. Those files flow directly into Music 21, MIT's Python toolkit for computational musicology, which can parse, analyze, and transform scores. Its Roman numeral analysis and harmonic function modules parse chord progressions and model functional harmony, while other modules support transposition, reharmonization, serial transformations, and windowed analysis for algorithmic insight or creative recomposition. Expose Music 21 as an MCP server, and LLMs can now invoke these capabilities through structured tool calls, turning natural language prompts like "reharmonize this in a modal jazz style" into validated Music 21 transformations before Music XML round trips back to tools like MuseScore Studio 4.6, whose SMUFL and VST3 support bridge symbolic notation to rendered performance. The result is an end-to-end pipeline where archival PDFs become conversationally editable, algorithmically analyzable, and professionally publishable, with MCP making music theory expertise accessible through dialogue rather than code. Formal verification for GPU kernels. As GPUs become the substrate for everything from model training to fast inference, formal methods are starting to meet the metal. Qt tackles a missing link. There's a Coq formalization of NVIDIA's PTX memory model, but nothing connecting Rust's compiler IR to it. By translating Rust's MIR to Coq and proving that MEMIR atomic synchronization compiles soundly to PTX under the PTX model for a realistic subset, Qt creates a path to verified GPU kernels, barrier correctness, data flow soundness, and race freedom under defined scopes. Limitations apply, e.g. global memory only, curated MIR subset, but the foothold is meaningful. The practical read: as Rust extends into CUDA SPR Vive via Rust CUDA and Rust GPU, a verified MIR PTX bridge can evolve toward CompCert-style guarantees. Given how subtle GPU ordering and scopes can be, linking language-level reasoning to the execution model is not academic hair-splitting. It's increasingly table stakes for safety-critical and high-assurance AI pipelines.